All right, here's one last integration by parts. This is a toughie because we're dealing with the differential equation dy dx equals the arc sine of x with an initial value of x equals 0 when y equals 0. So let's set up our integration by parts. The integral of u dv is equal to uv minus v du. Okay, so there's the setup right there. Well, if we deal with dy dx equals arc sine of x, I'm going to multiply both sides by that dx to start with. So I start here and I multiply both sides by dx. The reason I do that is so I can get my integral action going here. So dy is equal to the arc sine of x dx. Okay. Now, when I integrate this, the left-hand side integrates really, really nicely. The left-hand side, those are nasty-looking integral signs. When you integrate dy, you get y. When you integrate the other side, it's a little bit tricky. That's going to be our by parts, and I'm going to let u equal the arc sine of x. I'm going to let dv be equal to dx. And remember, when we're trying to determine what to set up to be u, at the way up the list, very much so towards the top, are the arc sines, the arc trig functions. So when I take the derivative of the arc sine, I get 1 over the square root of 1 minus x squared dx. And when I integrate this side, v equals x. So when I do u times v, I'm going to get x arc sine x minus the integral of v du, and that's going to be x over 1 minus x squared dx. Now all I have to do is make a u substitution here, and just to help you out a little bit, if I have x over the square root of 1 minus x squared, this is the same thing as saying x times 1 minus x squared to the negative 1/2. So if I let u equal 1 minus x squared, du is going to be negative 2x, okay, and dx. And so what I need, I've got x dx. So I'm just going to move this 2 over and have negative 1/2 du equals x dx. Okay, back over here to this problem again. Let's set up my u substitution. So what's going to happen next is I'm going to have y equals x arc sine x minus, I'm going to use some parentheses here, and I'm dealing with the integral of u, all right, to the negative 1/2 times negative 1/2 du. Okay, this guy is not too bad to integrate. So moving on down, y equals arc sine of x, x arc sine of x minus, and then when I integrate this, u to the 1/2, so that's going to be plus 1, u to the 1/2 power now, divided by 1/2, okay, times negative 1/2. All right, and the 1/2s cancel out. If I divide by a negative 1/2 and multiply by a 1/2, they cancel out, and this negative make positive. So I'm going to substitute my purple u back in here, and I'm going to get my general solution. Y equals x arc sine x plus the square root of 1 minus x squared. All right, there's your general solution right here. And we can use this guy and create a slope field. And then now we're going to just check out this general solution. Well, what do? We simply take 0 and put it in for y, and 0 and put it in for x. Okay? And what happens is when you do this, 0 times anything is 0. So I end up with 0 equals 1 minus 0 squared. So 0 equals 1 plus c. C is going to be negative 1. So the solution for this guy, for this differential equation, is going to be y equals x times the arc sine of x plus the square root of 1 minus x squared plus c. Now, this is a rich problem. There's a lot going on here. And so maybe this is a kind of a problem where you need to try and solve it on your own. Come back to the video, come back to the notes, see where you need a nudge, start again, and see where, if you can get to the point where you can solve this problem without looking at anything for help. And it is difficult, but also it's totally doable. Just take it one piece at a time. Maybe you have some different colors to keep track of all the different stuff that's going on. Okay?